Alright, welcome back guys. I'm not going to say nothing, we're just going to jump right into this. Okay, so for this first one we got a classic indefinite integral, just some throwback to good old calc. So the indefinite integral I got for you here is find the integral of cosine squared of x sine of x dx. So this one's pretty easy, but we're going to use a method that I'm sure you haven't seen in a pretty long time, and that is U substitution. Yes, our favorite. So the first thing we got to do is choose a U. In this case, it would be better to choose U as cosine. So with that U, you want to find its derivative so that you can have a du and you can actually solve the integral using U, using it in terms of U. So for this one's pretty easy. The derivative of cosine is negative sine of x, and if you notice in our original equation, sine is positive, so I'm just going to go ahead and divide this by -1 to get negative du, but then we get our sine of x. Alright, so then we take our u and du and we pretty much just plug it in to this original equation and make sure like the exponents, coefficients, and everything matches. So for this one, it's going to be the integral of u squared, because it's our cosine squared, and we can see that negative du is sine of x, so we're gonna have to put a little negative out there. All right, so this one's pretty straightforward. If we remember our little shortcut for solving integrals, you add 1 to that exponent and then you divide that exponent by the coefficient, which is in this case is 1. So make sure you remember that negative 1/3. And don't forget the constant. So all that's left to do is pretty much just plug what we have solved for u, which is cosine, back in for u. So we'll get that this integral equals -1/3 cosine cubed of x plus c. And boom. First one done. Okay, so for this next one, we got some more vector math. And this one is asking what is the angle between the two given vectors. So we got a vector, which is 4i plus 12j plus 6k. B is 24i minus 8j plus 6k. So for questions like these, whenever they're asking for angle between vectors, you're going to want to have the dot product in some fashion. You can find this equation on page 59 of the handbook. I'll have referenced in the description. But to do it when you have these vectors, you pretty much just multiply the i's, j's, and k's together and then add them. So for this one, we're going to have 4 times 24 plus 12 times -8 plus 6 times 6, which will give us 36. So now that we have that, let's just write down the equation that I was actually referencing from the handbook, and that is going to be a dotted with b is equal to the magnitude of a times b, the magnitude of b, cosine of theta. So for this one, we want theta, so let's solve for theta first. So we can divide the magnitudes, get them out of there. So that'll give us that, and then to find theta, we'll take the inverse cosine, which will give us theta is equal to the inverse cosine of a dotted with b over the magnitudes of a and b. So the last thing we need to find for this are these magnitudes, and that is extremely easy with vectors. You just take their coefficients and square them under a big old square root sign. So for the magnitude, put that. The magnitude of a is 4 squared plus 12 squared plus 6 squared, which will give us 14. So the magnitude of b is the square root of 24 squared plus -8 squared plus 6 squared. And that'll give us 26. So now that we have everything, let's just plug it into the equation. So theta is equal to inverse cosine, and we found the dot product, which is 36, over these magnitudes, which will give us 14 times 26. And that'll give us a nice theta of 84.32 degrees. Alright, so that'll do it for this part. I hope some of these helped you guys out, at least jogged your memory a little bit. But that's all I have for you for this one. I hope to see you in the next one.